Welcome back, guys. This is our second video lecture in astronomy. I'm excited to have you all here. We're going to be learning about the moon, the sun, and the earth today. So our agenda for today is to do our bell ringer and our vocab, just like every other day. We are going to also do the earth, moon, and sun doodle notes. That page in your notebook is going to look like this right here. Okay? So doodle notes, as with per usual, we are going to use color for those. They can be colored pens, colored markers. It doesn't matter much to me, but you are to be color coding these for your own use. It is linked to higher levels of learning and better retention of material, the use of color. So we use it. So if you will, our vocab today is just one word, ellipse. So if you will, go ahead and copy down your vocab, pause the video, and then unpause it when you're ready to get started again. We're going to move on. So our ellipse was our vocab word today. Our bell ringer, if you will, remember our bell ringer slide looks like this. It should be dated September the 3rd, please. True or false, so you can write 1 and 2. And you can write T and F. True or false, rotation is the Earth's movement around the sun. True or false? True or false, the Earth is an inner planet. True or false? Pause this, write them down, write down what you think, and then we'll go through the answers. So today we're going to learn all about, or a little bit about, we're going to touch on rotation and revolution. Rotation is not the Earth's movement around the sun. That is actually revolution. Rotation is the word that we use to describe the Earth's movement about its axis, so the actual spinning of the Earth. And then for our second one, true or false, the Earth is an inner planet. That one is actually true. So the first one is false, the second one is true. The Earth is an inner planet. We call them the rocky planets because they are consistent of rocky material. The outer planets are much larger, but they are gaseous. So that means that instead of being a solid, the planet is actually made of gas and vapors, right? Very cool, very fun stuff to study. There's a lot of physics involved in that as to why the inner planets are rocky and why the outer ones are gaseous. But it has to do with the gravitational pull of the sun and the material. So the heavier, more solid materials were pulled closer to the sun when the solar system was formed, and that's what created the rocky planets in the inner. Do you guys know, this would be a bonus question, do you know what separates the inner and the outer planets? It is actually an asteroid belt separates the inner and the outer planets. So there's a belt of asteroids between Mars and Jupiter. So if you will, go ahead and turn into your notes. Remember, again, they look like this. Go ahead and turn there. We're going to get started with our lecture. This is where we're going. So just to give you a general idea, the moon is actually smaller than the Earth, and the Earth is smaller than the sun, so just a general relative size here. We're starting with the moon. So the moon is a natural satellite of planet Earth. A satellite is a celestial body in space that orbits around a larger body. So the moon isn't one example of that. The moon will orbit the Earth once every month, so it makes a complete rotation around the Earth every 27 to 28 days, right? That's how we get the moon phases. Actually, we get the moon phases from the revolution of it around the sun as well. Again, pause it if you need to. Gravity is only 1/6 of that on Earth. On the moon, that is why we get these, the asteroids, the astronauts, right? Why they can kind of bounce around in space. That's because gravity is not as strong on the Earth or on the moon as it is the Earth. The gravitational pull of the celestial body, the moon's not a planet, the satellite itself, right? So it's not as large as the Earth, so it is not going to pull as much on something that is on it. So the gravity is less. For this right here, anything that's written that's not in your little text box, it was for when we do our presentations, our slides in person. They're sort of like thinking questions for you to do with your partner. If you would love to discuss them with somebody in your house, you're welcome to. If not, that's okay too. We will be asking them, though, in class, and it would be a good thing to just think about yourself. So the moon has 8 phases or shapes depending on the position of the moon relative to the earth and sun. The new moon actually looks black because, or you cannot see it for the most part, blacked out, because the sun light is not reflecting off the surface. So it's dark, right? So what we do see here on the moon, so if we were looking at a waxing crescent moon, right here, is actually what is reflected from the sun. Okay? So when the moon is in a waxing crescent, we can only see a little bit of the sun's reflection. During the first quarter, we can see half of it. Our waxing gibbous, we can see a majority of the moon lit up. And with our full moon, we can see all, or that the whole half of the moon that is lit up by the sun is in our viewpoint. So in this, the new moon, the half of the moon that is lit up, or the sunward side, is not pointing towards the earth. See? So this is what is actually happening here with the sun. So the sun is lighting up this white side. The dark side is what the sun is not lighting up. And you can see that the sun lights up half of the moon at all times, but we get the different phases because of the way that the moon is positioned between the earth and the sun, right? So the sun is lighting up half of the moon on a new moon, even though we can't see it. The sun is lighting up half of the moon on a first quarter, even though we can't see it. That's actually why it's called quarter, because we're only seeing a quarter of the moon that is actually lit up. We're going to talk more in depth about the moon phases in a later lesson, and we're also going to do an activity on it. Here's a funny cartoon for you. So what is with the shape-changing thing? Asks the earth. The moon says, it's just a phase I'm going through. Thought it was funny. You might not. That's okay. So the moon does not make its own light. About half of the moon is always lit by the sun. We just talked about that. The moon rotates and revolves at the same rate, so we always see the same side. Gravity causes the rise and fall of the ocean or the tides. We are not having the flashback because we've mixed-matched our units, but later we'll learn what type of tide that picture is showing. So if I ever ask you a question why we always see the same side of the moon, it is because the moon rotates and revolves at the same space. So we are always seeing the same side of the moon. We're moving on to Earth. Earth is pretty special. We live there. So Earth is the 3rd planet from the sun, and it is the 5th largest in the solar system. The temperature on Earth is perfect to allow water to stay in the liquid form. If Earth were closer to the ocean, or to the sun, the oceans would boil away. If Earth was farther away, the oceans would actually freeze. Earth is the largest of the inner planets. And we talked about this in the beginning lecture. What are the outer planets made of? Gases. We see this difference because of the gravitational pull on the sun. The sun pulled the heavier materials towards it as the solar system was forming. Therefore, the planets on the inner side of it or closest to it were made out of heavier, more solid material. So, yeah, see, it simply comes down to density and gravity. The solar system formed from a cloud of dust and gases. The dust had a greater density than the gas, and the particles clumped together to eventually form the rocky planets. The Earth takes 1 year to revolve. A revolution is how long it takes the Earth to revolve or go around the sun. It rotates every 24 hours. The rotating is how we get day and night. And the Earth is tilted on its axis about 23.5 degrees, and that is significant, and we'll talk about that in a later lecture about the seasons. The phenomenon that the tilt of the Earth's axis creates is the seasons. Earth is the only planet known to have living things. Why do you think Earth can support life? There are lots of reasons. Here's some for them. The temperature is just right to keep water liquid. Radiation from the sun powers photosynthesis. And temperatures are just right to not burn up living things, right? We have on the Earth the perfect system to sustain life. None of the other planets in our solar system have that at this current moment. And we talked about this when we talked about our telescope debate. They are searching for other planets that might have this capacity to support life, or at once, right? We're always looking for other life. Are there aliens out there? Are there not? And last but not least, the very largest of the celestial bodies we are going to talk about is our star, or the sun. Believe it or not, it is actually medium-sized. It is not large or small. Our star is average. This is one of the 100 billion stars in the Milky Way galaxy. So our sun, while very special to us, is not very special in terms of the galaxy, and even less special when we think about the number of stars in our universe. Look, this is from one of the telescopes. There's our sun. 90% of the planets known to us lie within about 2,000 light years from our sun as of July 14th. So that's that little circle, and we have so much more of the universe to understand. The only star in our sun is the only star in the solar system that we have. It's mostly made of hydrogen and helium gases. Tomorrow we're going to study in depth these gases and the processes that make the light that radiate the energy or create the energy from the sun. While it is the only star in our solar system, please do not get that misconception that you can only have one star. There are other solar systems that have 2 and possibly even 3 stars out there. Ours just happens to only have 1. The sun's gravity is strong enough to keep the planets in orbit. That's why we have the solar system. So the gravity on Earth is 9.8 meters per second squared. You should know that from physics class. If not, we'll learn it eventually. Jupiter's gravity is 24.79 meters per second squared. So Jupiter has a greater gravity than the Earth. And then the sun's gravity is 274 meters per second squared. So I want you to think about this in terms of moons for a second. So the Earth has a gravity of 9.8, and it has 1 moon. Jupiter has a gravity of 24.79, and it has 53 moons. So an object with a greater gravity, greater gravitational force, is more likely to have more satellites or things orbiting around it. So because the sun's gravity is so large, it is very likely, and it makes a lot of sense when you think about it in terms of that, as to why the planets revolve around the sun. The sun has no surface, and it has a magnetic field, and it rotates on an axis. So if you were to try and think that maybe you would like to stand on the sun, 1, it is way, way, way too hot for you to stand there, and 2, you couldn't stand there anyways because it's not solid. The sun, like I said, is made up of mostly hydrogen and helium, which we know are gases, not solids, though it does have the helium is more concentrated towards the core of the sun, but they are still both gases, so it is not solid. Nuclear energy, or fusion, provides the energy needed for life on Earth. Fusion is what causes the brightness and light from the sun, the energy. We're going to talk about it in depth tomorrow. We're going to have a lot of fun. I love teaching about fusion versus fission. When fusion happens, 2 molecules come together, they fuse, and they release 1, a neutron, and 2, a lot of energy. We'll talk about it more tomorrow. And lastly, the sun is huge. It contains about 99.9% of the mass in the solar system, and over 1 million Earths could fit in the sun. Here's an example just to show you what's going on, right? The Earth is this tiny, tiny little dot right there, and that is the sun in terms of relative size, right? Even Jupiter looks small when compared to the sun. And that is the end of our lecture. Have a great day. Don't forget to submit your notes.